All right, guys, super short lesson today. This is absolute value inequalities, special cases. So, we've already learned how to solve these. Today, we're just going to talk about two special situations that could possibly pop up when you start solving these. So, if I look at number one, again, our goal is to isolate the absolute value bracket. In this case, it already is it's already isolated. So, I can go ahead now and rewrite. So I got the first one. Come over here, rewrite it, but remember you flip the sign and you change the answer to its opposite. Okay, when I do that then, positive 2. Start solving, subtract 5, and we get x is greater than or equal to negative 7. And then over here, subtract 5, x is less or equal to negative 3. All right, so I'm going to go ahead and graph that. And x is greater than or equal to negative 7, so that's a closed point. It's got to be shaded to the right. And then x is less or equal to negative 3. Again, it's a closed point, and that's shaded then to the left. So you see what's going to end up happening is that everything on this number line is going to be covered. Okay, so this is going to be what we call all real numbers. So either use a big fancy cursive R or just write out all real numbers. And again, that means that you can plug any number into this inequality and it's going to work. It's going to make a true statement. Okay, number 2. So again, double check that it's isolated, the absolute value bracket, which it is. So I come down and rewrite it. N over 2 is less or equal to negative 3. And then I make my second problem, switch the symbol, change the answer to its opposite, and then solve. So times 2. So I get n is less or equal to negative 6. Come over here, times 2, and we get n is greater than or equal to 6. Okay, so if I graph this, n is less than or equal to negative 6. Well, that's going to be right here. Be going this way. And n is greater than or equal to 6. Okay. Now, here's the problem. Let's say I choose a number like right here, 7, and I plug it back into the solution set. So I say 7 over 2 is less or equal to negative 3. Well, 7 divided by 2 is 3.5, and the absolute value of 3.5 is not less than or equal to negative 3. So that doesn't work. Okay, let's say I pick a number out here. Let's say I go negative 7. So I'm going to come over here, show my work. So I do negative 7 in here over 2 is less or equal to negative 3. Well, that's going to give you negative 3.5 in the absolute value. But if I take the absolute value of that, then you get 3.5, and that is not less or equal to negative 3. So that's not true. Okay, so when we have absolute value inequalities, it's important that you take your answers and you double check, you plug it back in to see if it's going to result in a statement that's not true. Okay, so in this case, when it's going both directions, it's going to be all real numbers. But if you have a graph that's separated like this, take your answers, test them back in to verify to see if that solution is true. If not, then we say it's no solution. All right. The rest of these problems, some are going to be, just normal answers. Some are going to have no solutions. Some are going to have all real number answers. All right, you guys go ahead and do number 3. Number 4. Number 5. Six, 7, 8, 9, 10, 11, and 12.